So this was the question that we had at the end of the probability video. Two friends, they decide to meet at a restaurant, and they decide that they will meet next day at between 3 o'clock and 4 o'clock, and that the condition is that each one of them will wait for the other for 10 minutes. You had to find the probability that they will meet. Two friends decide to meet between 3 o'clock and 4 o'clock, and each will wait for the other for 10 minutes. Probability that they will meet. Alright, proceeding ahead. The solution to this problem, what we'll do is we'll do it through graphs. Graphical probability. Alright, let's see how we'll do it. Okay, 3 o'clock, between 3 o'clock and 4 o'clock, we have 60 minutes, a time span of 60 minutes. Alright, proceeding ahead. Let's say there were two friends, A and B, and let's say if A arrives at X minutes, if A comes in at X minutes, he'll be able to meet B if B was there X plus minus 10 minutes. If B was there X plus minus 10 minutes, because they both have decided that they'll meet within 10 minutes of their arrival, which means that A will be able to meet B if B arrives at max after 10 minutes of A's arrival, X plus 10, or A will be able to meet B if A manages to come after B has already arrived, which is X minus 10. If B is already arrived, and if within 10 minutes if A arrives as well, they'll be able to meet. So these are the two only equations that we'll be solving. So you can listen to it through an example. You can imagine through an example. Let's say if A arrives at 3:20, he'll be able to meet B if B at max arrives at 3:30, or if B was already there at 3:10. So both they'll meet. Okay, let's see how we'll do it through graphs. I'm plotting x-axis and y-axis, and I'll plot 60 minutes each on both the axes. 60 minutes each on both the axes. So this is the maximum area. This is the maximum area that is useful for us. Alright. Okay, so now one equation was x plus 10, that one will meet the other if the other arrived within 10 minutes, or if the other was already there 10 minutes prior to one's arrival. X plus 10 and x minus 10, two equations. Let's see if we can plot them. Let's work with the first equation, x plus 10. Okay, I'll plug in the values, and I'll try to spot the 2 points, and then I'll connect those 2 points to form a line. Okay, I'm putting x equal to 0. So y will become 0 plus 10 is 10. Y will become 10. So this is the point 0, 10. Okay, I'm plugging in another value to have another point. I'm plugging in value x equal to 50. So y will become 50 plus 10, 60. So this is the next point. I'll join these 2 points to form a line. Okay, the next equation, x minus 10. Again, plugging in the values, I'll put x equal to 10 to get y equal to 0. So this is the point. Moving on, I'll put x equal to 60 to get y equal to 60 minus 10, 50. So this is the second point. I'll join these points again. So this is the area confined between these two lines. So this is the required favorable area. I'll try to find this area. What I can do is, out of the entire square, if I can delete the area of this triangle as well as the area of this triangle, what I'll be left with is area of this part, the favorable part. Okay, let's see if we can find the area of square. Area of square is 60 by 60, 60 into 60, which is 3600, and the area of triangle is half into base into height. The base is of 50 units and the height is again 50 units as well. Half into 50 is the area of triangle. Since we have 2 of them, we'll multiply the area by 2. So the area of these 2 triangles is 2500 units, square units. So we are left with the favorable area is 3600 minus 2500, which is 1100. So the required probability is 1100 upon 3600, which is 11 by 36. So the probability that they will meet is 11 by 36. That's it. I hope you understood the concept. You can, of course, you can go back again and review it, and of course you can keep enjoying the sleepy classes. Thank you.